Hello everyone, and a warm welcome to Multimodal Language Processing. My name is Xaver Funk, and I recently had the chance to really nerd myself into this topic because I'm studying neuroscience, and this was kind of something that I had to do. And yeah, that's what I want to share with you today. So what I've been doing recently also is learning Arabic and a little bit of Mongolian. And mostly what I did was I had these streams of auditory signals that maybe came from the SML audio, and I tried to match those to symbols that were representing these, right, in the book. And I kind of had this feeling that this is incomplete, so there's something missing there. And while I was, on the other hand, studying a lot about multimodal language processing, how gestures influence processing and stuff like that, I came to the conclusion, well, yeah, there's something missing. In our world today, we are all literate, so we mostly think of languages as these auditory signals, these mouth noises, and these symbols that represent these. But there's so much more going on in face-to-face communication. And yeah, I want to make this point clear with a virtual experiment. So I want to invite you to, first of all, listen to this audio excerpt from an Easy Languages video, and I give you the subtitles here with the English translations as well. And yeah, so basically these are auditory signals in Dutch and sequences of symbols in Dutch and English. And for the people learning Dutch, please just ignore the English, just to make it a little bit harder. And the people who know Dutch, please close your eyes so that you don't see it at all. So let's go.
Zijn nog andere bestemmingen waar jullie misschien nog een keertje naartoe willen?
Oh, genoeg.
Ja.
Heb je even?
Je hebt in Scandinavië Lofoten. Dat is iets heel anders dan Zuid-Afrika, maar volgens mij is daar super mooi. Meer berglandschappen zo. Daar zou ik echt wel een keertje naartoe willen.
Ja, ik wil heel graag naar Australië. Al vanaf ik kind ben eigenlijk. Dus dat staat nog wel hoog op mijn lijst, zeg maar.
En samen willen we ook.
Wij zijn al heel lang vrienden en we willen al heel lang met z'n tweeën op vakantie, maar dat is nog steeds niet gelukt.
Nee.
En als jullie samen gaan, waar zouden jullie dan naartoe willen?
Ja, dan maakt het dus niet uit.
Maakt het niet uit.
Als wij op vakantie gaan met z'n tweeën is het altijd leuk.
So, so when I was listening to this at first, I was, because I know some Dutch, I was understanding quite a lot, but kind of not everything. And then when I watched the video that goes with it, it was kind of a different experience. And that's what we're going to do now. So just watch the video, and if you can, see how these two women that are interviewed here are interacting with the interviewer and between each other.
Zijn er nog andere bestemmingen waar jullie misschien nog een keertje naartoe willen?
Oh, genoeg.
Ja.
Heb je even?
Je hebt in Scandinavië Lofoten. Dat is iets heel anders dan Zuid-Afrika, maar volgens mij is daar super mooi. Meer berglandschappen zo. Daar zou ik echt wel een keertje naartoe willen.
Ja, ik wil heel graag naar Australië. Al vanaf ik kind ben eigenlijk. Dus dat staat nog wel hoog op mijn lijst, zeg maar.
En samen willen we ook.
Wij zijn al heel lang vrienden en we willen al heel lang met z'n tweeën op vakantie, maar dat is nog steeds niet gelukt.
Nee.
En als jullie samen gaan, waar zouden jullie dan naartoe willen?
Ja, dan maakt het dus niet uit.
Maakt het niet uit.
Als wij op vakantie gaan met z'n tweeën is het altijd leuk.
So I hope this worked, and you felt a little bit different now. And even for the people who don't know Dutch, I hope you could kind of follow what was going on. And even if you didn't, the point I want to make is that messages are not only auditory, they're also visual. We have a lot of non-auditory articulators, like 43 face muscles, for example, and then 2 times 34 muscles in our hands, and then even more in our arms and in our torso. And the people in this video really knew how to use these. So, for example, we had a lot of facial movement going on, and like you see on the top here, you see how she raises her eyebrows, and then you have this head tilting at the end that really points an emphasis on what she's saying. And then there's a lot of gaze switching as well. So that's right in the beginning where she says, oh, genoeg, heb je even? So, oh, there's so much that I want to see. Do you have some time? But she doesn't really say time. She says, heb je even? Do you have a little? And for me, when I was only listening, I didn't quite get what she was saying. But when I saw how she addresses the interviewer, I kind of got it afterwards. So yeah, then there's of course manual gestures like hoch op mijn lijst, that's that one here, hoch op mijn lijst, and she says berglandschap, so that's mountain range, and then lang geleden, a long time ago, right? So there's a lot of messages that are supported with these manual gestures, and then there's also stuff like this nose scratching, where we don't even know is there something to it, or is it just a nose scratching? Does it have carry also some information? We don't know. And then lastly, also arm and torso movements. And also, if you watch at the top here, you have nodding. So you see how these two kind of nod together, and it really gives you the impression of how good friends they are, right? And then if you look at this bottom part here, that's my favorite part of the video, you really have this complex orchestration of different gestures, and they are turn taking. So the girl on the right says something, and then the one on the left answers like perfectly, and then you have gesture, and then the pulling the hair back, right? So there's so much going on between them, and it really gives more than just the auditory message, right? So note that there's something that our brain has to achieve here, mainly two things. So it has to segregate all of the stuff that is not important for the message, that's the segregation problem, from the important stuff, and then take all the important stuff, all the auditory and the visual information, and put it together to a coherent message. And that's our binding problem. And all of this, note that all of this is under really tight time constraints when you're turn taking, when you're having a conversation and you say something, then the other person says something, and there's not that much time between turns. And if you need more time, then that also has a meaning, right? If you take time, then that means you're hesitating to answer. Maybe there's something going on with you emotionally, so you don't want to have that as well. So yeah, so basically this is really a huge computational problem for your brain. And well, how did your brains do? Did you feel the video was more difficult than the raw audio? Did you understand more, or did you understand less? Did you feel more in the scene, maybe, catching more information between the lines? And well, for me, at least as you might guess, for me it was way easier to follow with the video and to integrate these gestures. And this is kind of a paradox. So how come that processing more signals simultaneously is easier than processing speech alone? And this also was shown in the literature, so people have made experiments with this, and this is really a surprising facilitation. For example, then there are a lot of studies. I'll just give you one example. So in this study, they showed people a prime. So this was some video of an action that somebody did. And then they showed the people different videos. And the videos were either completely congruent. So what was said was the same as the gesture and was the same as the prime. So in that case, it would be chop and doing the chopping gesture. And then there were different conditions where either the speech was congruent, incongruent, and the gesture was congruent, or the speech was incongruent and the gesture was congruent. And then they had also weakly incongruent stuff, like this for chopping, but this is actually cutting, so this is only weakly incongruent. And then this twisting, which is strongly incongruent. And then people had to press a button for yes, either if the speech or the gesture was related to the prime, and no if neither speech nor the gesture was related to the prime. And what the people found out that there was differences in response times and also in the proportion of errors that people did as soon as there was something incongruent. And from that, the authors come to the conclusion that really speech and gesture are two sides of the same coin, and they mutually interact to enhance comprehension. And now the big question is, of course, how does our brain achieve this surprising facilitation? And we can look back at turn taking to maybe get some clues there. So on average, a turn take takes only about 0 to 200 milliseconds, which is a fifth of a second. You can see this in this video how fast she is responding right now. After this, like this is an instant, right? And this is quite extraordinary because producing a single word actually takes about 600 milliseconds. So if I just prompt you to say a word, you would take 600 milliseconds to say it. So there's something going on. It seems like we are predicting already what we are going to say before the turn of the other person is finished. and we already prepare our turn. So there's something that's going on that has to do with prediction. Most language use in conversation has to be based on prediction somehow. And this is quite nice because prediction is anyways the current hype in neuroscience nowadays. It's basically a good candidate for the overarching function of the brain. And many people think that what we are doing in our daily lives is basically constantly computing and updating probability distributions. And this applies both to action, to perception, and also to language. So this will be then a rephrasing of the problem we had before as a prediction problem. And this becomes then, given the preceding context, so given all the words that come before, what word is most likely to come up next, right? To make this more clear, let me give you a quick example. So imagine I come to you and I say, without any more context, I would like to. And then you don't know what I'm going to say next, right? It could be any of these, for example. I would like to drink, eat, walk, and so on. And now, if I shape my hand in the form of a C and I put it to my mouth like this, while I say I would like to, then your probability distribution over these words changes in such a way that drink is much more likely to be the next word, and maybe eat also a little bit, but the other words probably not, because you can associate this gesture with drinking and a little bit with eating, because it's also something that you put something to your mouth, but mostly this is commonly understood as drinking, right? So in this way, gesture adds context to prediction and helps this process of predicting. And that also helps then comprehension. And we can actually measure prediction using neurophysiology. So this is EEG. EEG stands for electroencephalography, and it's basically putting electrodes on the scalp and then measuring the brain activity that's below it. And if you do this, you can measure brain activity basically. And what people usually do is they give people these sentences. So these could be normal sentences like this one. It was his first day at work. Or it could be so-called garden path sentences. So these are sentences that are somehow manipulated artificially to elicit some response, right? So this would be, he spread the warm bread with socks. So you may have a weird feeling now in your head because nobody spreads his bread with socks. And this weird feeling, if we would measure you with an EEG, would constitute this reaction here. That's a so-called N400, N because it is a negative polarity, and it's 400 milliseconds after the word. So all of this above here is just electrical activity, right? And you have this really pronounced peak when there's a violation of the semantics, like with socks. And this is also taken to be a prediction error. So you did not predict socks. You predicted Nutella, for example, or honey, but not socks. And this is reflected in this N400 prediction error. So people are doing this a lot, like showing these sentences that are somehow manipulated. We have another example here. This is another topic. If you write in all caps, you have this kind of response, for example. But what I want to do now with you is bring you more to the cutting edge of what is currently done in multimodal processing research. So the trend is to go away from these artificially constructed sentences and more towards naturalistic language comprehension. So using actual stories, actual sentences that are not manipulated in any way. And this will be combined with computational linguistics. How that works, you will see in a bit. And also, yeah, with that, you can look at multimodal processing if you just add a video to the audio that you make people listen to. And how this might look like is like this. So this is one study that is currently not published officially yet. It's already on the archive. And I want to use this to illustrate to you how we might research naturalistic language comprehension. So the general plan is get some per word measures. So this would be these ones here. So for each word, there's some value attached. And then we can use these as regressors in a big linear regression model. so using fancy statistics. And with that, we're basically asking our data, how well are you predicted by these regressors, right? And for example, this one here is surpriser, and this is closely related to predictions or prediction errors. And so this is the negative log probability of a word given all the words that come before it. Okay, so this is the context basically, and this is some word, W. So this is basically telling you how unpredictable is a given word. And this measure is based on computational language models. So for example, they would take the whole corpus of a language and then see which words occur after each other, and thereby get to this value of how predictable it is. And then they have another thing here. They use the fundamental frequency of each word as a pitch indicator to control for prosody, which is also pretty cool. So they let loose their linear regression models with these predictors. So they have a surprisal value for each word, for example, a prosody value for each word. Then they indicated where there are meaningful gestures happening. And yeah, then also mouth movement. And what came out of this, one finding that might be interesting for us now, is that for meaningful gestures, the N400 is less negative. So you can also see this here. For a meaningful gesture, this blue line, you see that this is a lot less negative than the red line where gestures are absent. And then there's also, that's why I told you about surprisal, an interesting interaction between gestures and surprisal. So the higher the surprisal, so the less unexpected a word, the stronger this facilitating effect of gestures is, which is also really interesting. Then this is a similar study that I actually got the chance to work on with a colleague. And so what we did here, we had a measure of entropy. This measures basically the uncertainty about the next word. So if you think back to the example we had before, where I was telling you, so I would like to, and then something, but without context, that would be really high entropy, really high uncertainty. You don't know what word is coming next, right? Then we also had surprisal. We had word frequency, how often the word came up. IVC it's a measure of it's abbreviation for instantaneous visual change. So how much the actor moved while we were showing this to the people. And then speech envelope. This is basically a measure of the level of the sound. And what we found is that this was, by the way, an fMRI experiment. So we can look at which regions are active during some condition. And for words where the surprisal was really high, there were these regions in red active. And for words where the entropy was really high, these regions in blue. And now if we look at the interaction with gestures or the entropy condition, we can see that when there were gestures present, we had really specific activations compared to when there were no gestures present in situations where there's high entropy, so high uncertainty. So with this tools, we try to get into the processes that underlie prediction in language. So let's take a step back and have a look at kind of a more global evolutionary perspective. We know from primate research that gesture and gaze are crucial for communication. You can see this in this video. This ape right here does this gesture, and this signals to its mother to pick her up, right? So these are bonobos, and you can see right now this pick me up gesture. And Federico Sano from the Max Planck Institute for Evolutionary Anthropology could show that these gestures get more and more ritualized to the point where it becomes only a small wristband with the arm and one gaze to instantiate this carry behavior, right? So you see that there's also kind of prediction involved. The mother has to predict what the child is wanting to do, right? Going from this to only this. Then building on this, there are some authors that propose that speech and gesture have a common origin. And the idea here is that through these ritualized gestures that we just seen in these bonobos, after time there will be a proto-sign language evolving, which then at some point will be accompanied by sound as well, evolving into a proto-speech language. And then the proto-sign and the proto-speech will reinforce each other more and more until language emerges. And another point here, that or an observation, those of you who have tried sign language, it kind of feels surprisingly natural, right? So if speech is the true communication medium for humans, why is it that sign language feels so real, so natural, right? And then another point that goes into this theory is that voluntary hand movements came before voluntary breathing, and you need voluntary breathing to articulate yourself, right? So also gestures are complementary to speech. You can more easily show spatial relations between things. And then if you look at child development, the same pattern. Gestures develop before speech, and actually pre-speech turn-taking is faster than later. So if you're a baby and you gesture, the turn-taking with your mother, with the communication is quite fast. It's almost adult-level turn-taking. Then as you learn language, it gets way slower, and only in middle school it gets back to the adult-level turn-taking. So what's the point, right? What does all this mean for language learning? So for this, let's do another time travel back to 1768 and meet this French Jesuit monk, Claude François Lizard de Radovière. And he wrote this book, De la manière d'apprendre les langues, back in the day, where he reflected on how we should teach people languages. And interestingly, this is basically the grandfather of the Asselmann method, and also the Methode Toussaint-Langenscheidt, or also called interlinear version. So this would be this sheet here. This was a way people learned languages at the turn of the previous century. And you can see here that you have the Spanish at the top, then some transliteration in the middle, and on the bottom, the German. And this is kind of similar to what Asselmann does, right? So this is really interesting, but that's not the point here. What he also did in this book is to compare LL1, so first language acquisition, with second language learning. And he noted that it seems that for the first language, parents show their children pictures and enact words or concepts and encourage the children to do the same, like this little boy does here. But for second language acquisition, all we do is give people these vocabulary lists and expect them to learn it just like that. So this is kind of an interesting point. And since then, it has been shown, and this is actually pretty robust. I was really surprised that it has been a really robust finding that gesture-enriched material enhances learning. So in this study, for example, people tried to teach English-speaking people Japanese words, and they had 4 different training conditions. So 1 only speech, 1 repeated speech, 1 speech plus incongruent gestures, so gestures that would not match, and then congruent gestures. And this is the interesting condition, right? And then they tested the people after encoding for 3 different times, after 5 minutes, after 2 days, and after 1 week. And also they tested them under forced choice, so this is basically multiple choice, and free recall, so just prompting the people with the word, and then they come up themselves with the answer. And so these numbers here are basically the proportion of correct answers that people give. And you can see that across the board, the speech plus congruent gestures condition is way superior compared to the other ones, which is interesting. And so you would maybe think that the point is, okay, so we just use videos instead of audio, right? And this is what I would call multisensory enrichment. And there's nothing wrong with this. This is really, really useful. You have these YouTube channels like Easy Languages. I'm not sponsored, by the way, where you have conversations with real people that from time to time make gestures, and you get the full conversation thing, right? Then you have these one-on-one videos, like this one with from Mandarin Corner, where there are also a lot of gestures involved. So the host, Eileen, really tries to integrate a lot of gestures. But this is actually not the point. I mean, this is cool, but I think you already do that. The point is way deeper. So there's another thing going on, not only when you watch gestures, but when you enact them. This is called the enactment effect. This was actually coined in 1980 by two Germans, and they called it first the to effect, which translates literally to do effect. And you can see why people chose to call it the enactment effect, because it sounds way more fancy. But I really like the to effect. It sounds funny. So anyways, the point is that action words or phrases, or this is what Engelkamp and Krummacher noticed, that action words and phrases are remembered better if they are acted out or accompanied by a gesture. So if you would learn the phrase chopping garlic, then if you enact it actually while learning it, you will retain it way better. And this effect is also really well replicated. And this was also really surprising to me, because it is virtually not at all translated into actual teaching. Nobody does this. Nobody tells the students to enact things, right? Enact words, enact anything. And it has been well replicated across tasks, across materials, and also across populations, across children, adults, even clinical populations, people with Alzheimer's, people recovering from stroke. Somehow people made them learn words and enact the words, and it worked better than without enactment. And also, this is not only true for action words and concrete words, but also abstract words. Anything you can somehow find a representation with gestures for, you can use this enactment effect. And this is way more powerful than multisensory enrichment. And we can call this sensory motor enrichment, because you use your senses and your motor. So this ties in with another really interesting development in the neurosciences called embodied cognition. Basically, this is the idea that many features of cognition, and these might be concepts, categories, reasoning, or judgment, are shaped by aspects of the body. And these would be the motor system, so how we move, the perceptual system, what we see, what we feel, what we hear, and so on, and also bodily interactions with the environment. And you might see where I get with this. If you think about concepts and categories, what are words if not concepts and categories, right? So we might ask the question, how are words represented in the brain? And there's this really funny study. They showed people words that had strong olfactory associations, which means they either stink really hard or they smell really well. And in case you're looking for some inspiration for your Spanish poem, you can go to this publication and search through the list of words. This is also this is only a small sample. There are a ton of really strong smelling words in the study. And yeah, so basically what they found is that when they showed people these words, as compared to words that did not smell that much, some regions in the brain that are associated with olfaction, so with smelling, lighted up. And this is has been extended as well to action. So on the left here, these are all the regions that light up when you move your foot, when you move your fingers, or when you move your tongue. And on the right here, these are regions that light up when you read leg-related words, arm-related words, or face-related words. And you can see that this more or less, these activations fit each other, right? So in some way, leg-related words are stored where you also move your leg. Arm-related words are stored where you also move your arms, and so on. So we can think about words actually as functional networks, like this. And note that words are experience-dependent functional networks, and experience is connected to the body, right? So, for example, you surely have not only read and heard the word garlic, you also have smelled garlic, you touched garlic, you tasted garlic, and really importantly, you chopped garlic. So when you read garlic, you not only have the core language areas in yellow here activated, but also subcortical olfactory areas, some gustatory areas, so for taste, action areas, right? And visual areas as well. So what I want to tell you here is, think about this when you learn languages. Did you do the same, or did you do the same for Knoblauch, for example, German word for garlic? When you learn German, do you actually get into this huge associative network? So, and that's the point, basically. We're coming to the end. The point is that language is multimodal. You should use sensory motor enrichment when learning languages, and thereby embody your languages. And if you want to learn more about this, and also for me to give credit, this is basically where I got most of my input from. These are 4 big review articles that discuss all of this stuff. So yeah, that's basically it. Thanks for listening, and hoping for some cool questions. So, okay. Does this explain why conversing in my target language on the phone feels much harder than in person or with video? I would most certainly guess so. So this thing with the phone is also something that I have experienced quite a lot. So I have lived in Chile for some time, and I got myself a Chilean SIM card. And I didn't give this number to a lot of people, but somehow this number got to people that were, I don't know, trying to sell me something. And I would get a call from somebody, pick up the phone, and I would not understand a single word. Like, Chilean Spanish is already really hard, and then it's completely out of context. I don't know what this person wants from me. And then it's just, and I'm like, sorry, I don't understand you, I don't understand you, I don't understand you, over and over again. And yeah, I mean, if you're on the phone, there's also like a little bit of noise maybe. And I really have the feeling that makes, especially in a foreign language, conversing that much harder, because you don't see the mouth movements. It's not that clear of a sound. You don't see anything else. And yeah, I would say so. Cool question. Has there been any research on this topic with neurodivergent individuals, e.g. autistic, ADHD, who sometimes have more difficulty interpreting nonverbal cues, facial expressions, and so on? I would guess so. Like, I mean, especially for autistic people, there's a lot of research on language processing in general. But I don't know of any studies that are specific with specifically for multimodal processing, but I think that there are quite a few. Actually, the experiment that I showed you with the one that I worked on as well in the middle of the presentation, the entropy stuff, we also did this with schizophrenic patients, but we have not looked at the data yet. So once this publication is done, then somebody else will deal with the clinical data with the schizophrenic people. And in general, for schizophrenics, there's a lot of like language-related abnormalities, and I think for autistic people as well. I'm not sure about ADHD, but yeah, it would be a really interesting thing to look at this for autistic people, for sure. And maybe people did this. You can look it up. I don't have anything on my in my head right now, but yeah, there should be something. For abstract words, would nonsense enactment still help, or should one use signs from established sign languages? I think one of the studies that I glanced over actually tried this. So they had some gestures that were nonsense. I don't know if it was with abstract words or with concrete words, but they used nonsense gestures, and they still had an effect, but it was smaller, right? So if you try to make this, to integrate this into your studying, I would suggest that you try to find an enactment that is as sensical as it gets, right? I mean, it's not that it's impossible to get enactments for abstract words. You just have to be a little bit more creative. And I think the more creative you will be, the more effective, like similar to mnemonics, like the more crazy a mnemonic is, right, the easier it is to remember. I could see the same effect with enactments as well. And if you should use signs from established sign languages, I think if you want to, that's a cool idea, because then you automatically also learn the sign language. And when I was preparing this presentation, I actually thought about this. Like, why do we learn languages? Like, if I now start learning a language, why do I not learn the sign language that goes with it, right? I think it would make things easier, because you actually have the enactment ready for you. And it's just a cool thing, right? You can talk with so many more people, and also, I think in general, people should learn sign languages regardless. This became really clear to me at the Polyglot gathering in 2019 in Bratislava. We were on some ship where there was a party, and there was loud music. And then there were some people who knew sign languages. Maybe they are listening right now. So they just started, we were like on the dance floor, and instead of screaming into each other's ears like people usually do, they just started to sign, and it was so smooth. Like, why should we communicate with sounds when you can do it with gestures, right? I think for many situations it would be a lot easier. So yeah, if you can use the signs of your target language, I think that's a cool idea. Sounds like trying amateur theater in your target language could be a nice idea. Yeah, does sound like that. Indeed. Yeah, I can totally see that. Are there any studies combining multimodal language processing with persons who cannot hear, or persons who communicate exclusively or primarily through a sign language? There is a study that I came across while researching, but I didn't look into it. If you want the reference, you can reach out to me somehow, and I can see if I can find it and send it to you. I didn't look deeply into it, and I think I wouldn't find it now quickly. Yeah. So again, there's something done, but I can't recall it from my head right now. What might be some practical implications for our day-to-day language learning? Well, so there's two things, maybe more things, but let's start with two. So first of all, when you learn a new word, try to get the whole picture of the word, right? Like the garlic example. Try to imagine how it smells, how it feels, how you chop it, and try to enact it. Take the moment and really try to activate the whole functional network of this word. And then the other thing, the other thing was also just to use input with video. If you're learning with some input, look up if you find some interesting channels on YouTube or something. And then also, that might have not been clear from my presentation, if you are conversing with people, use signs. Like, I can't, like, I don't know if people do this naturally in general. I think I kind of do it if I talk in my target language and I'm not sure about a word, I will try to make sure with my hands that somehow something gets like to the other person. Then, so what I'm going for is that the other person recognizes what I'm trying to say and then gives me the word, right? So like the example with the glass of water, I would, if I don't know drink in some language, I would try to write, I want to write, and then have the other person give me the word, because I'm actively reducing the uncertainty that the other person has that is trying to predict what I'm going to say by giving gestures, right? So that would be my 3 practical implications for now. Could it work to learn sign language along with our target language, e.g. Korean Sign Language alongside spoken Korean? Was it more effective to make up your own gestures? Yeah, so this is something that that I don't know. Again, I think it's worth trying to do this with the sign language. I mean, there's a system of really really fitting gestures that people use, and there might be it might actually be a good idea to try this out, to use sign languages as you're learning the actual language to get this enactment working. Might be more effective than making up your own gestures. I mean, if you make up your own gestures, you have the advantage that during the process of coming up with a gesture, you are engaging your brain in a specific way that's not there if you just get the gesture from somebody, right? So there might be an advantage there, but the other advantage is, of course, time that you can save and the ability to communicate with people that can't hear. So yeah, I think that's open for exploration for sure. Since gestures give context, do you think gestures can fully replace verbal languages? Well, you see it in sign language, right? Again, people that sign don't really speak, and they get along pretty nicely. Another question would be if our society as a whole can do without verbal. I mean, that's another question, but I think you can restructure society in a way that everybody can communicate with gestures for sure. And according to some people, it was like that before speech developed, right? Has there been any research on the brain of a polyglot or hyperpolyglot's brain? How it gets stimulated compared with a monolingual or bilingual brain? So yeah, there has been some research, not much. If you're interested in this, make sure to check out my presentation on this topic from last year's gathering and also from last year's conference. The conference one is not up on YouTube already, but the gathering one, and there in the end, I show a study that was done on polyglots and hyperpolyglots. Actually, only hyperpolyglots, I think. And so they put people in an fMRI scanner and just gave them language material. And what they found is that the language network was less active than for monolinguals. So if you listen to something, there's some areas on the left side of your brain that light up. You have some typical areas like Broca's area, Wernicke's area, and some other ones. And they found that for polyglots, this lighting up is less. And the interpretation was that the polyglot's language network, through extensive practice, has become more and more efficient at dealing with language. And therefore, it needs less activation. So this is one thing that you observe quite often, that when there's some process that you get really good at, in your brain, the activity that you see goes down because the network gets more efficient. So that's why this paper was aptly titled "The Small and Efficient Language Network of Polyglots and Hyperpolyglots." And then so you can look this up as well. And they also made them listen to different languages. And there, the better known the foreign language was. So the first experiment was completely in English, their mother tongues, and then the second experiment, they used their target languages, like the second best language, third best language, and so on. And there, the lesser known a language, the less active the language network, and the better known, the more active. So you have kind of the opposite effect. And then they interpreted this as reflecting that the more you know in a target language, in a foreign language, the more of your language network gets gets recruited, the more context you have. Yeah, so you have this effect of getting really efficient for your mother tongue and getting more of the whole message for the better you know a foreign language. Yeah. So this was the last question. All right. Thanks for listening. Thanks for the thanks to the organizers for organizing this. This streaming works really well. I'm really impressed. Thanks, guys.